Now, the topic that is Kirchhoff's rules. Kirchhoff's rules are very useful for the circuit analysis. It implies that Kirchhoff's rules are very useful to find the potential differences across the components connected in the network, as well as with the help of Kirchhoff's rules one can find the current flowing through different branches of the network. Network means the complex connections of components like registers, cells. So that is complex combination of these components, means maybe in series, in parallel, and sometime mixed mode connection. Now, there are two rules suggested by scientist Kirchhoff. One that is known as junction rule and another one that is known as loop rule. Junction rule suggests this thing: at any junction in the given network, the sum of the currents entering to the junction, that is equal to the sum of the currents leaving the junction. Actually, this junction rule, that is the consequence of law of conservation of electric charge. Now see here, as per law of conservation of electric charge, we know this thing: at any point, charge will not be accumulated, charge will not be destroyed, and new charge that will not be produced. So here the current is constituted due to flow of charges. So the same junction rule that we can represent like this: the total amount of charge entering the junction, that is equal to the total amount of charge leaving the junction per unit time. So this one is the consequence of law of conservation of electric charge. Then second one, then after loop rule. Loop rule suggests this thing: the algebraic sum of the changes in the potential differences around any closed loop involving resistors and cells in the loop, that is equal to 0. Actually, this loop rule, that is the consequence of law of conservation of energy. After all, the potential, that is nothing but energy, and the potential difference, that is the change in energy. So in the closed loop, if we take the algebraic summation of the changes in the potential differences across each component, it implies that we are taking the change in energy of the unit positive charge when it is moving from one end to other end of the component. Then that change in energy that we take here. So when resultantly the summation comes to 0, it implies that the energy is conserved. એટલે કે યુનિટ પોઝિટિવ ચાર્જ એક એન્ડ થી બીજા એન્ડ ઉપર ગયો કોઈ કોમ્પોનન્ટમાં, and suppose its energy decreases. પછી બીજા કોમ્પોનન્ટમાં suppose one end to other end એ મૂવ થયો, and suppose its energy increases. So in this way, if we take the algebraic summation of the change in potential differences, or in other words we can say energies, and finally if we get 0, it implies that the energy of that unit positive charge remains constant one. Okay, so this is the loop rule. Clear up to this one? Let's understand these two rules with example. Suppose, as shown in the figure, we have a network in which Some resistors and cells are connected as shown in the figure. Now, first of all, we have to understand the junction and the loop for given network. Which point in the network, that is called junction. So the point or the terminal in the network where more than two components of the circuit are connected, that is known as junction. And when a closed circuit is formed by connecting the components, then it is known as loop. Now see here, this particular network given to you. So in this particular network, there are two junctions. One junction that is A and second one that is D. Because see, at A, this 30 ohm resistor is connected, this 40 ohm resistor is connected, and this 80 volt battery is connected. So more than two components are connected. Similarly, at D also more than two components are connected. So in this particular circuit, terminal A, or we can say point A and D are the junctions. Clear to all of you? Now, how many loops are there in this particular network? So, loop means a closed circuit in which the components are connected. So here total 3 loops are there. See, A, B, C, D, A. This is one loop. Second one, that is A, D, E, F, A. And third one, that is this outer one. A, B, C, D, E, F, A. So total 3 loops are there in this particular network. So now the concept of junction and loop is clear to all of you. Now, as per Kirchhoff's junction rule, we can write here, see, consider the junction A. So for junction A, see the total amount of current entering the junction, that is I3. Only one current is entering to junction A. But two currents, I1 and I2, these two currents are leaving the junction. So we can write, as per Kirchhoff's junction rule, I3, that is equal to I1 plus I2. This is the junction rule. Clear to all of you? Now here, to understand the loop rule, consider the loop A, B, C, D, A. Okay? Now, start from A. Now, we are moving from A to B, then after B to C, then after C to D, then after D to A. So, loop will be completed. So, A to B, there is no component, so no potential difference. Then B to C. Now, current I1 is flowing through this 30 ohm resistance. Now when through this 30 ohm resistance I1 current is flowing, then between two terminal of this 30 ohm resistor, the potential difference as per Ohm's law, we can write V equal to IR. So potential difference, that is 30 I1. So here it is 30 I1, that is the potential difference between 30 ohm resistor. Okay, later on we will discuss about these positive negative signs. Then after, when we move from C to D, there is no component, so no potential drop. Then after we move from D to A, so here is the battery of 45 volt. So potential difference between two terminal of the battery, that is 45 volt. So here 45 is taken. Then after, see the current I3 is flowing through 1 ohm resistor. So potential difference across 1 ohm resistor, that is 1 I3. Then after, I3 current is flowing through 40 ohm resistor. So potential difference, that is 40 I3. Now here we have to take the algebraic summation of all these potential differences which we calculated in this loop. Now see here, first think about this 30 ohm resistor. Now we know this thing, current always flows from high potential to low potential. So through 30 ohm resistor, the current is flowing from left to right. So this left terminal of 30 ohm resistor, that we can say is at higher potential, and this right side terminal of 30 ohm resistor, that we can say is at lower potential. Now when we move from B to C, then first high potential terminal is there, and then after low potential terminal is there. When we take the potential difference, difference means final minus initial. So for first terminal, initial potential, that is high potential. For this second terminal, which is final terminal, for that the final potential is low potential. So final minus initial potential, so here you will get answer negative. So negative sign is introduced here. Clear up to this one? Then after, when we move from D to A, so at that time, first negative terminal appears here. Then after, positive terminal of the battery. Negative terminal of the battery is at lower potential. Positive terminal, that is at higher potential. So if we take here final minus initial, so this will come to positive. So here 45 volt potential difference, that is taken as positive. Now here, simply remember one thing. See, for this 30 ohm resistor, we consider the potential difference, that is minus 30 I1. હવે શોર્ટકટ મેથડ યાદ રાખજો અહીંયા કે જો current is flowing from B to C and you are also moving from B to C. So when you are moving through the resistor in the direction of current, then always take the potential difference across that resistor is negative. તો હવે એના કરતા ઊંધું, if you are moving in the opposite direction of the current flowing through the resistor, then take the potential difference across it as positive. હવે બેટરી માટે શોર્ટકટ યાદ રાખજો કે through the battery, when you are moving from negative terminal to positive terminal, then take the potential difference of battery positive. હવે એના કરતા ઊંધું, if you are moving through the battery from positive terminal to negative terminal of the battery, then take the potential difference negative. So now see, when you are moving from D to A, so through 1 ohm resistor, you are moving in the direction of the current, because direction of the current is the same one. So 1I3, that potential difference you have to take negative. Again, through 40 ohm resistor, you are moving in the direction of the current. See, direction of the current, that is B to A, and you are also moving B to A. So potential difference across 40 ohm, that is taken here negative, so minus 40I3, and now this algebraic summation of the potential differences, that is equal to 0 in this loop. This is loop rule. Clear to all of you? Now consider the loop A, D, E, F, A. So when you are moving from A to D, now see, when you are moving A to D, so through the resistor 40 ohm, the current, that is in the opposite direction, then your considered path. So take the potential difference 40I3 across this 40 ohm resistor, that is positive. Again, through 1 ohm resistor, you are moving in the opposite direction of the current. So again, take the potential difference 1I3 positive. Then through this battery, you are moving from positive terminal to negative terminal of the battery. So potential difference that you have to take negative, minus 45. Then after D to E, when you are moving, so 20 ohm resistor is there, and through this 20 ohm resistor, this I2 current is flowing from E to D. So you are moving D to E, current is flowing from E to D. So you are moving in the opposite direction of current. So again the potential difference 20I2, that is taken positive. Then E to F. So you are moving through this 1 ohm resistor in the opposite direction of this current. So again the potential difference 1I2, that is taken positive. Then through this 80 volt battery, you are moving from positive terminal to negative terminal. So you have to take that potential difference minus 80, and this is equal to 0. So in this way, the second rule that we can apply to the loop. Clear to all of you?